Hello friends, in this video we are going to see some introductory part as well as some basic concepts in fluid mechanics. So let's move on to video. A matter exists in either solid state or fluid state. Fluid state is further divided into liquid and gaseous state. In fact, the same matter may exist in any one of the three states, namely solid, liquid and gases. For example, water, which ordinarily occurs in a liquid state, may also occur under natural conditions in a solid state, such as ice, and in gaseous state as vapor. Solids, liquids, and gases exhibit different characteristics on account of their different molecular structure. All substances consist of vast number of molecules separated by empty space. The molecules are continuously moving within the substance and they have an attraction for each other. But when the distance between them becomes very small, of the order of diameter of molecule, there is a force of repulsion between the molecules which pushes them apart. In solids, the molecules are very closely spaced, but in liquids, the spacing between the molecules is relatively large, and in gases, the space between the molecular is still larger. As such, in a given volume, a solid contains large number of molecules, a liquid contains relatively less number of molecules, and gas contains much less number of molecules. It thus follows that in solids, the force of attraction between the molecules is large, on account of which there is very little movement of molecules within the solid mass, and hence solid possess compact and rigid form. In liquids, the force of attraction between the molecules is relatively less, due to which the molecules can move freely within the liquid mass. But the force of attraction between the molecules is sufficient to keep the liquids together in a definite volume. In gases, the force of attraction between the molecules is much less, due to which molecules of gases have greater freedom of movement, so that gases will completely fill the container in which they are placed. It may, however, be stated that in spite of larger mobility and spacing of the molecules of the fluids, for mechanical analysis, a fluid is considered to be continuum, that is, continuous distribution of matter with no voids or empty spaces. This assumption is justifiable because ordinarily the fluids involved in most of the engineering problems have large number of molecules and the distance between them are small. Another difference that exists between the solids and fluids is in their relative abilities to resist the external forces. A solid can resist tensile, compressive, and shear forces up to certain limit. A fluid has no tensile strength or very little of it, and it can resist compressive forces only when it is kept in a container. When subjected to shearing force, fluids deform continuously as long as force is applied. Inability of the fluids to resist shearing stress gives them their characteristic property to change shape or to flow. This, however, does not mean that fluids do not offer any resistance to shearing forces. In fact, the fluids flow, there exist shearing stresses between the adjacent fluid layers, which results in opposing movements of one layer over the other. Amount of shear stress in a fluid depends on the magnitude of the rate of deformation of fluid element. However, if a fluid is at rest, no shear force can exist in it. The two classes of fluids, namely gases and liquids, also exhibit quite a different characteristic. Gases can be compressed much readily under the action of external pressure, and when external pressure is removed, gases tend to expand indefinitely. On the other hand, under ordinary conditions, liquids are quite difficult to compress, and therefore they may for most of the purposes be regarded as incompressible. Moreover, even if the pressure acting on the liquid mass is removed, still the cohesion between the particles holds them together so that the liquid does not expand indefinitely and it may have free surface. That is the surface from which all the pressure except atmospheric pressure is removed. Now let us see definition of a fluid. In view of the above discussion, a fluid may be defined as a substance which is capable of flowing. It has no definite shape of its own but conforms to the shape of containing vessel. Further, even a smaller amount of shear force exerted on the fluid will cause it to undergo deformation which continues as long as force continues to be applied. A liquid is a fluid which possesses a definite volume which varies only slightly with temperature and pressure. Since under ordinary conditions liquids are difficult to compress, they may be for all practical purposes regarded as incompressible. It forms a free surface or an interface separating it from the atmosphere or any other gas present. A gas is a fluid which is compressible and possesses no definite volume, but it always expands until its volume is equal to that of container. Even a slight change in temperature of gas has a significant effect on its volume and pressure. However, if the conditions are such that a gas undergoes a negligible change in its volume, it may be regarded as incompressible. But if the change in volume is not negligible, the compressibility of the gas will have to be taken into account in the analysis. A vapor is a gas whose temperature and pressure are such that is very near to liquid state. Thus, steam may be considered as vapor because of its state is normally not far from that of water. We can classify the fluids as below. The fluids are classified as ideal fluids and practical or real fluids. Ideal fluids are those which have no viscosity and surface tension and they are incompressible. As such, for ideal fluids are no resistance is encountered as fluid moves. However, in nature, the ideal fluids do not exist and therefore these are only imaginary fluids. The existence of these imaginary fluids was conceived by mathematicians in order to simplify mathematical analysis of the fluids in motion. Fluids which have low viscosity, such as air, water, may be however treated as ideal fluids without much error. Another type, that is practical or real fluids, are those fluids which are actually available in nature. These fluids possesses the properties such as viscosity, surface tension and compressibility. Therefore, a certain amount of resistance is always offered by these fluids when they are set in motion. Now let us see the application of fluid mechanics. Fluid mechanics is that branch of science which deals with the behavior of the fluids at rest as well as in motion. In general, the scope of fluid mathematics is very wide, which includes the study of all liquids and gases. But usually, it is confined to the study of liquids and those gases for which the effect due to compressibility may be neglected. The gases with appreciable compressibility effects are governed by the laws of thermodynamics, which are however dealt with under the subject of gas dynamics. Now let us see some basic introductory part, some information that a study person should know, that is, these are some systems, metric and English system of units. Metric in short we will call it as American system of units and English we will call it as British system of units. Each system is further divided into two types as on the basis of gravity as gravitational and having no any other references of gravity, that is absolute. So in these systems the units of length, time, mass, force and temperature are as shown in table. As it is a confusing part that each country or each part of the world will follow a particular type of system that may be creating confusing situations. So for that purpose, it was decided at the 11th General Conference of Weights and Measures held in Paris in 1960 to adopt a unified, systematically constituted, coherent system of units for international use. This system of units is called International System of Units and is designed by abbreviation SI units. More and more countries of the world are now adopting this system of units, and six basic units according to SI systems are tabulated as shown in figure. For length, we will use unit meter, mass, we will use kilogram, time, we will use second, electric current, we will measure it in ampere, temperature in Kelvin, and luminous intensity in candela. The units for some of the derived quantities have been assigned special names and symbols. Some of the important derived units with special names and commonly used in fluid mechanics in SI and metric gravitational systems of units are given in further table. Area is in meter square, volume in meter cube, velocity in meter per second, angular velocity in radian per second, acceleration in meter per second square, angular acceleration in radian per second square, frequency in hertz, discharge in meter cube per second, mass density in kg per meter cube, force in Newton. 1 Newton force is also the product of mass into acceleration. So kg into meter per second square. So Newton is equal to kg into meter per second square. Pressure or stress having same units, that is Newton per meter square. Elastic modulus in Pascal. Weight density in Newton per meter cube. Dynamic viscosity in Newton second per meter square. Momentum in kg meter per second. Moment of momentum kg meter per second. Entropy in joules per kg Kelvin. Specific heat in joules per kg Kelvin. Gas constant in joules per kg Kelvin. Thermal conductivity watt per meter Kelvin, etc. Certain units, though outside the international system, have been retained for their general use in system also. These units are as shown in table. Area of land may be in hectare, time may be in minute, hour or day. Mass in ton, volume in liter, dynamic viscosity in poise or centipoise, kinematic viscosity in Stokes, and pressure of fluid in bar. This further table is stating various prefixes which are used in case of multiplier. We all know 1 kilogram is equal to 1000 gram. So 1000 means 10 raised to 3. So when multiplier is 10 raised to 3, we will use the prefix as kilo. So these prefixes are for 10 raised to power 1, it is deca, then hecto, then kilo, mega, giga, tera, beta and exa. In case of decreasing order, they are For 10 raised to minus 1 it is deci, 10 raised to minus 2 it is centi, then milli, micro, nano, pico, femto and auto as shown in table. That's all. Thank you.